Split bolts can be used for tapping into continuous wire runs for both ungrounded and grounded conductors, as long as they are properly insulated. Regarding the proper usage of split bolts when using split bolts for tapping into wire runs, firstly, choose a split bolt with the correct size for the wire you are tapping into and the wire you are connecting. Secondly, strip the insulation off the wire where the tap is to be made. Thirdly, place the wire you are tapping into inside the split bolt. Fourthly, insert the connecting wire into the other side of the split bolt. Fifthly, tighten the bolt to make a secure connection. It is very important to properly insulate the connection. Wrap electrical tape or heat shrink tubing around the split bolt to prevent accidental contact with other wires or surfaces. Split bolts are commonly used for grounding, as they provide a secure and reliable connection. When used for grounding, it is important to use a green grounding screw to connect the grounding wire to the split bolt. Split bolts can also be used for tapping into non-grounding wire runs. However, it is crucial to ensure that the connection is properly insulated to prevent short circuits or other electrical hazards. Some important notes to keep in mind: firstly, always use the appropriate wire size for the split bolt. Secondly, make sure the wires are clean and free of corrosion before making the connection. Thirdly, tighten the bolt securely, but do not over-tighten. Fourthly, properly insulate the connection after making it. Fifthly, consult electrical codes and regulations for specific requirements in your area. When selecting a split bolt connector, the size of the connector is paramount. The connector must be appropriately sized to accommodate the conductors being joined. Using an undersized connector can lead to overheating and potential failure, while an oversized connector may not provide a secure and reliable connection. Manufacturers typically provide sizing charts that correlate conductor size with the appropriate split bolt connector size. These charts should be consulted to ensure proper selection. The material composition of the split bolt connector is another critical consideration. Connectors are commonly made from copper, aluminum, or a combination of both. Copper connectors are generally preferred for copper conductors due to their excellent conductivity and resistance to corrosion. Aluminum connectors are suitable for aluminum conductors, but when joining copper and aluminum conductors, a bimetallic connector specifically designed for this purpose should be used to prevent galvanic corrosion. This type of corrosion occurs when dissimilar metals are in contact in the presence of an electrolyte, such as moisture, and can lead to a weakened connection and eventual failure. Surface preparation of the conductors is essential for achieving a reliable electrical connection. Before installing the split bolt connector, the insulation should be carefully stripped from the conductors without nicking or damaging the underlying metal. The exposed conductor surfaces should then be cleaned to remove any dirt, oxidation, or other contaminants that could impede electrical conductivity. A wire brush or abrasive pad can be used for this purpose, followed by the application of an antioxidant compound specifically designed for electrical connections. These compounds help to prevent oxidation and improve the contact between the conductor and the connector. Proper installation torque is crucial for ensuring a secure and reliable connection. The split bolt connector should be tightened to the manufacturer's specified torque value using a calibrated torque wrench. Under-tightening the connector can result in a loose connection with high resistance, leading to overheating and potential failure. Over-tightening the connector can damage the conductors or the connector itself, reducing its ability to maintain a secure connection over time. The use of a torque wrench ensures that the correct amount of force is applied, providing a consistent and reliable connection. Insulating the connection after installation is essential for preventing electrical shock and short circuits. The exposed portion of the split bolt connector and the surrounding conductor should be completely covered with electrical tape or heat shrink tubing. Electrical tape should be applied in multiple layers, overlapping each layer to provide a watertight seal. Heat shrink tubing offers a more durable and professional-looking insulation solution. It is available in various sizes and materials, and when heated, it shrinks tightly around the connection, providing a secure and insulated covering. Grounding is a critical aspect of electrical safety, and split bolt connectors are often used in grounding applications. When used for grounding, the split bolt connector should be connected to a grounding electrode conductor, which provides a low impedance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse, interrupting the flow of electricity and preventing electrical shock or fire. The grounding electrode conductor should be sized according to the electrical code, and the connection to the split bolt connector should be made using a green grounding screw or other approved method. Regular inspection and maintenance of split bolt connections are essential for ensuring their long-term reliability. Connections should be visually inspected for signs of corrosion, looseness, or damage. If any issues are detected, the connection should be repaired or replaced immediately. In harsh environments, such as those with high humidity or exposure to corrosive chemicals, more frequent inspections may be necessary. Retorquing the connections periodically can also help to maintain their tightness and prevent failures. Electrical codes and standards provide detailed requirements for the installation and use of split bolt connectors. These codes and standards are developed by organizations such as the National Electrical Code, and they are designed to ensure the safety and reliability of electrical systems. It is essential to consult the applicable electrical codes and standards before installing any electrical connections, including those using split bolt connectors. These codes and standards specify the types of connectors that are approved for use in different applications, as well as the installation methods and torque requirements. Different types of split bolt connectors are available for various applications. Some connectors are designed for use with specific types of conductors, while others are more general purpose. Some connectors are insulated, while others are not. It is important to select the appropriate type of connector for the application to ensure safe and reliable connection. For example, insulated split bolt connectors are often used in underground applications to provide additional protection against moisture and corrosion. Specialized split bolt connectors are also available for splicing high voltage cables. These connectors are designed to withstand the high electrical stresses associated with high voltage systems, and they are typically installed by trained professionals. The use of split bolt connectors is just one aspect of proper electrical wiring practices. It is essential to follow all applicable electrical codes and standards when installing electrical wiring, and to use qualified electricians for any work that requires specialized knowledge or skills. Improperly installed electrical wiring can pose a serious safety hazard, leading to electrical shock, fire, or other injuries. Therefore, it is important to take the time to learn about proper wiring practices and to follow them carefully. In addition to split bolt connectors, other types of electrical connectors are available, each with its own advantages and disadvantages. Wire nuts are commonly used for joining smaller gauge wires, while crimp connectors are often used for making connections in automotive and marine applications. Terminal blocks provide a convenient way to connect multiple wires together, and they are often used in control panels and other electrical equipment. The choice of connector depends on the specific application and the types of wires being joined. When working with electrical wiring, it is important to always disconnect the power before making any connections. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and other hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety. The NEC Section 110.14 C covers terminal connection torque. Terminals for more than one conductor and terminals used to secure equipment grounding conductors must be identified for the number and size of conductors and the torque requirements. Section 314.16 covers the number of conductors in outlet, device, and junction boxes, and conduit bodies. Boxes must be large enough to provide free space for all enclosed conductors. The volume of a box must be legibly and permanently marked on the box. Section 310.15 covers ampacity, which is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Section 310.16 contains tables that provide the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius in free air, based on ambient air temperatures of 30 degrees Celsius. It's important to use the appropriate ampacity for the conductor size and insulation type to prevent overheating and potential fire hazards. For example, a 14 AWG copper conductor with THHN insulation has an ampacity of 15 amps at 60 degrees Celsius, 20 amps at 75 degrees Celsius, and 25 amps at 90 degrees Celsius, according to NEC Table 310.16. However, the 15 amp value would be the appropriate choice for a 15 amp breaker because of the limitations of 240.4. The NEC section 250.122 covers equipment grounding conductor sizing. The size of the equipment grounding conductor is based on the rating of the overcurrent protective device protecting the circuit. For example, for a 20 amp overcurrent device, the minimum size equipment grounding conductor is 12 AWG copper or 10 AWG aluminum, as per NEC Table 250.122. This ensures that the equipment grounding conductor can safely carry fault current back to the source in the event of a ground fault. NEC 300.11 covers securing and supporting wiring methods. Wiring methods must be securely supported and fastened in place. Cables must be supported every 4.5 feet for horizontal runs and within 12 inches of boxes, cabinets, fittings, or other terminations. This prevents strain on connections and ensures the wiring remains in place. Proper support is essential for maintaining the integrity of the wiring system and preventing damage. NEC Section 408.36 covers overcurrent protection for panel boards. Panel boards must be protected by an overcurrent device with a rating not greater than the panel board's rating. This protects the panel board from overloads and short circuits. Panel boards must be readily accessible and not located in hazardous locations. The overcurrent device provides protection for the entire panel board, preventing damage from excessive current flow.